All right, I'll start by introducing myself. My name is Dean Brooks. I am a freelance analyst and statistician at a little company called Ecros Analytical. My topic today is choosing better samples by understanding size laws. Now, what I'm going to do is I'm going to explain how to display financial data in a way that makes it easier to see the relationship between the dollar values and the sizes of vendor organizations. And I'm going to explain why you would want to do that, why that's a useful thing to do from an audit perspective. And then I'm going to show you how to do it in Excel. And this is not something that's commonly done. There will be some sort of novel concepts, things like logarithmic scales, which auditors don't normally deal with. But we'll go through this step by step. And since we're only going to deal with one example and one fairly straightforward idea, I don't think that there'll be anything here that the math phobic will panic at. So let me talk about the title for just a moment here. A size law is basically a relationship between items in a set or items in a database. So you have a file, you have a set of financial transactions, you have all the bills from all your vendors. And the size law says how many of the bills are small, how many of them are large, or it says how many come from small vendors, how many come from large vendors, or, and this is the tricky part that we're going to deal with today, you can have a size law that relates two variables together. So it says how many small bills come from small vendors and how many large bills come from large vendors. So you get a more complex kind of size law that involves more than one variable. So we're going to be dealing with size laws, and we're going to be dealing with how to display the information in a way that makes sense. So let me take you to the first slide. Okay, why are we doing this? Why do you care? As auditors, I'm sure you're familiar with sampling, and I'm sure you realize, this is not news to you, sampling is relatively inefficient. When you run any kind of test on audit data, any kind of large corporate database with tens of thousands of items, the test will produce thousands of red flags. It might be 7% of the total, it might be 5%, it'll vary depending on the test, but it will be so many that there's no chance at all that you will be able to look at all the flagged items. You will never, be able to pull up manually or read line item by line item all the items that are flagged as being suspicious or problematic. So you, of course, have to sample. And typically, the sampling is relatively random. You just pick the items out of a bin, more or less, or you weight them by dollar value. Either method is a random way of deciding how to proceed. And if you find an actual problem by that method, it's a little bit like holding a winning lotto ticket. It's like, you had thousands of items, and you managed to find one where there was an actual fraud. And, there aren't all frauds. Fraud is still relatively rare. So you're doing very well if you manage to do that by this method. What we'd like to do is we'd like to understand the structure of the data. We'd like to understand these size law relationships, and then to choose our samples more scientifically. Now, I'm not even going to talk about the actual sampling process today. I'm not going to go that far. All I'm going to do is help you to grasp the relationship between the variables. So it's like the first step in making your sampling better. All right. So this is also not news if you spend any time looking at data. Financial data is highly skewed. And all that we mean by that is that the values have a large range and they're not evenly distributed. So for example, in a corporate database, you have invoices that are worth $1, you have invoices that are worth $10 million, and the proportion is not even. There are a lot more dollar invoices than $10 million invoices. Similarly, if we're looking at vendors, you can have a vendor who only bills you once a year or once in its entire history. Or you have a vendor who sends you 1,000 invoices or 1,000 a month. And again, that distribution is typically skewed towards small vendors. There's a lot of vendors who send you 1 or 2 invoices in the course of the year, and relatively few who send you thousands. So this means that most of the activity in your file is relatively small and not really material. I mean, it's not really a success to detect an error in a dollar invoice. It might be a symptom of something serious happening elsewhere. If there are enough dollar invoices that are wrong, that after a while turns into real money. But this is a problem that really doesn't have a solution right now. It really is not handled well in the audit community. Because what you're trying to decide is whether to look at problem items, whether to search simply for an individual invoice out of context that is bad, or whether you're looking at problem vendors, and whether you would have greater success by trying to identify those vendors that generate duplicates or fraudulent efforts. And it's a subtle problem, and I hope to impress upon you in the next 15, 20 minutes just why it's not handled well and what sort of thinking you have to engage in order to handle it better. So as I was saying, we need more insight into this data pattern before we can even hope to devise a better sampling plan. Our objective for today, just to reiterate, is not to do a new sampling plan, but just to look at the data in a new way and to realize that there's something going on here that we haven't understood very well and we need to understand. It's not just that the range of values goes from $1 to $1 million. And it's not just that vendors go from, single-time vendors to vendors with thousands of transactions. It's the fact that those two variables have a relationship, that the number and size of individual invoices varies with vendors. So a large vendor handles invoices in a different way, and the data has a skew, it has a trend, it has a size law that we need to know about. It ought to be something that's in our minds as we're preparing our sampling plan. It ought to be in our minds as we're trying to decide, for example, whether we're trying to find a problem vendor or a problem item. So that's what we're going to try and accomplish. I'm going to take you into Excel in a moment and show you some graphs. We're going to try and find the typical relationship between invoice size and vendor size. We're going to display that relationship using a log-log graph. And that means that the two scales, the X and Y scales on the graph, are going to be logarithmic. And I'm going to define all these terms, and I'm going to show this to you firsthand in a moment. But that's going to be the big takeaway from this lesson, is that you're going to look at vendor size versus invoice size on a log-log graph. And you're going to hopefully be enlightened about just how complex your data is. And this won't get us to better sampling. In one day, we really can't do that. In a half hour, we really can't do that. But it will lay a foundation for thinking about that. It'll motivate you, I hope, to start looking for better ways to sample. So here we are in Excel. We have a sample data file. This is from a big Fortune 500 vendor, or rather Fortune 500 company. It's vendor data for a year. There are about 3,600 vendors in this file. And you can see by the dollar values that the total is in the billions. This is a very large company. And what we've plotted here in these two columns, or rather these three columns, column C, which is column C, it is the number of invoices submitted by a given vendor. Column D is the total dollar value for the year covered by those invoices. And then, of course, column E is just the average value. So we have $848 million worth of transactions for the largest of the vendors. And that was broken down into 19,619 individual invoices, and thus the average is about $43,000 per invoice. Now, the first thing I want you to notice is that there's some extreme variation, even in this tightly knit group of high-value vendors. Now, there's no vendor on the page right now that didn't do at least $24 million worth of business. And that's the high end. There's not a lot of people who have that kind of relationship. But even in this group, we have one that did 19,000 individual transactions, and then a little further down, we have one that did 22. Here's one with 10,000, here's one with 53, 11,000, and 60. So it's not obvious, just at a glance, what the trend is, what the relationship is between the number of invoices and the total volumes. It's not something you can just guess by looking at the data. And I'll just scroll up a little bit and you can see. Here's $19 million worth of business, 3 individual transactions. We scroll a little further. You can see it going up and down. You can see the variation. 3,800 different transactions, $10 million, 85, and 10. And this persists all the way down. There isn't a point where you stop having this kind of variation. There's 3,000, there's 11. See what I'm saying? It is a very, very random relationship. At the first glance, there's no pattern. There's no rule. Oh, you see now, here's a vendor. It's the highest value single invoice vendor in the set. This vendor did $2.2 million worth of work and charged it all to one invoice. So we've got this data set. I'll just scroll through a little bit more of it. You can see I've sorted it, and you can see that eventually, when you get down low enough, these numbers start to come down. But here's a $42,000 vendor, and he submitted 866 individual invoices. Now this is expensive in terms of processing. This is like $49 worth of invoice, and then who knows how many dollars worth of processing costs. So these are important items to notice too down here at the bottom end, or further down in the scale. And if we go down to the very bottom, we get to all these vendors with one invoice each. And there are many of them. There are hundreds of them. There are probably, if we have from 1 to 5, there are thousands of them in that range. So we have this very unwieldy data set. We want to know what the pattern is, and we think maybe we could learn something by graphing. Let me show you what happens when we graph it by the normal Excel method. Now this is the standard linear scale in both the X and Y directions. You see you've got number of transactions at the bottom. And as we saw, it looked like the largest was somewhere in the range of 20,000, and that's confirmed here. The total vendor volume, I've actually omitted a couple of the very top guys. If you look closely, at the top of the scale is $200 million, and we know that there was at least one vendor that was above that. So I've cut off the top scale to try and make this a little more readable. But I haven't succeeded. If you look at the plot of points, it's really not very informative. It really doesn't tell you a whole lot. Now, Excel provides various trend tools. You can just say, I want this graph to have a trend line. And in this case, I've asked for the linear trend line. And the linear trend line shows, not surprisingly, that the total volume increases with the total number of transactions. But you don't really get the sense from looking at this graph that you've learned anything useful. You don't really get the sense that you know something about the data that you didn't know a moment ago. It's not the right format. It's not the right kind of graph. Now, one thing that you might try doing, and this is like the first obvious step, is graph that third column, column E, as opposed to graphing column C and D, and see if the average dollar value tells you something that the total volume didn't. So we'll scroll down, because I've already done this. It doesn't tell you very much at this scale either. It doesn't tell you, it's the same problem, because the data is highly skewed. You can't see, you can see it's all crammed into this little corner. So what we need is we need a different scale on which to present the data. Once we have the appropriate scale, the relationship will become clear. Now, this scale is logarithmic, and I just want to pause here because a lot of us are a long way from high school science classes where we learned about logarithms. All we mean by a logarithmic scale is that instead of proceeding by equal increments like 2,000 and 4,000 and 6,000, as you see on the scale below, this is a bottom scale, it proceeds by powers of 10. So it goes from 1,000 to 10,000 to 100,000 in a multiplying fashion instead of an adding fashion. So it's really, conceptually, it's not that difficult. You don't have to kind of get all bent around the axle about it if you just think of it as a multiplier. So we go from, in this new layout, we go from one transaction, which is the left-hand value and it's the lowest you could get, to 10 transactions, to 100, to 1,000, to 10,000. And of course, we saw when we looked at the data, there are some with over 10,000 transactions, there's quite a number of them. So we see there, that's where the data winds up, somewhere in the range 1 to 10,000. But the way we've done this, we've grouped them by size, by relative order of magnitude. And we see that there's approximately the same number of transactions in each bin, as it were. There's about as many transactions, or at least it seems so from the dots, between 1 and 10, or between 10 and 100, or between 100 and 1,000. When we look at the Y scale, we see the same thing happening. We know that there are occasionally transactions worth $1 or $10, but most of them are worth more. And as we move up the scale, we go from 1 to 10 to 100 to 1,000. We see the scatter plot. That's what this is called. The scatter plot places most of the data in the range from $1,000 to about $1 million in total volume. Most vendors are in that range. Okay, so I hope that I haven't sort of lost anybody here plotting this on the log plot. What I want is I want you to see that the trend is now visible. Now we can draw a line through these plots and we can say, look, there's the total dollar volume increases with the number of transactions. And that's a very basic relationship that you would expect to have. I mean, if I asked you just out of the blue, what do you expect? Sure, more volume, more transactions. Now we can be more precise. We can say, but what's the slope of the line here? How steeply does the relationship climb? We could imagine it's climbing more steeply or climbing less steeply. We can sit down and try and quantify how much of a climb there is. In particular, we want to know, does volume go up faster than the number of transactions? And you can't tell that from this drawing. You can if you're a mathematician and you look at the little equation at the top. This Excel supplies a trend line equation. And you can tell if you know a little bit of math that this exponential means that it does climb faster because the exponent is greater than 1. But I won't subject you to exponential stations. I'm not going to drag you all into that. We're just going to look at this drawing and say, yes, there's a trend here. It's going up. Volume and transactions go up together. And we can't tell just yet which one goes up faster. The way we can break it down and determine which one goes up faster is by taking the average instead of the total volume. Now here, we have the transactions as before on the bottom, but we're looking at average invoice size, not total volume. And average invoice size is going up. The trend is upward. That means that a small vendor not only submits fewer transactions, the average value of that transaction is small. So you've got a linear, or not, it's not actually linear, but a consistent relationship between invoice size and vendor transactions. All right, so I've relatively quickly I've gone through the typical way that Excel presents the data, which isn't very helpful, and then this kind of funky log plot, which is much more helpful and which kind of illustrates the trend in the data far more clearly. And I know you're asking, yeah, but how do I do that? So let's go back, now that I've shown it all to you, let's go back to the beginning, and we'll just go through step by step, and by the end, you should be able to do this for yourselves. So first we'll go back to the vendor totals. This is the original data. And you can just take all this data, you can just grab the whole file, and you can make a graph in the usual way using Excel. But I want to point something out that you might not be aware of. Not everybody does this. In Excel, you can do a variety of charts, including a scatter chart, and that's what this is. You can do different kinds. We're going to do one with no lines connecting the dots because there is no trend in this data, or the trend remains to be discovered. So we want the dots to be all separate, and it'll look like that, which is what you saw earlier. So if you do that, you get the plot that we showed, we looked at first. And you can play with it a little bit. There's our guy with 19,000 transactions and $848 million, right? And you might be tempted just to get a better glimpse at the rest of it, just to take him out. And then it looks a little better, right? But it's still not what you want. Now, one of the things that's going to be a problem when you do a log plot as opposed to this standard plot is that you cannot have an item with zero value. Now, Excel is relatively forgiving in that regard. I can go up here and I'll show you. You see all these ones with no entry? Okay, it will ignore these. It will tolerate you making a graph with these. I'll just do that and see what I mean. You just go in and you say, make this axis, format axis, scale, logarithmic. If you have this is an older version of Excel. If you have the newer version, it'll be slightly different, but it'll still have a box with its name on it. You just click it, and now it'll produce a log scale on the x-axis. And you see, it had some blanks in there, but it just ignored them. It didn't give me a warning message or anything. It just went ahead and did it. So now we've got log scale on the bottom and a conventional scale on the left, on the y-axis. So let's make the y-axis conform to the same rule. And there's our plot. Now this is the raw data. This is the raw totals for the vendors. And as I said before, you can't tell from looking at this whether whether the trend is in favor of the vendor totals or in favor of the invoice total. Whether the trend, it means that the invoices are increasing in number faster than the total vendor dollars, or whether the total vendor dollars are increasing faster than the invoices. You can't really tell from looking. It's just too messy. And asking Excel to decide it for you, you can say add trend line, linear, and there now you get a warning. Now you get a little message saying, by the way, quit putting negative or zero values in there. But you'll notice Excel kind of is forgiving. It'll let you do that. Now, this is one of those sort of funky deals that, again, I don't want to overburden anybody with a lot of math. But a linear trend line on a log plot doesn't look so good. It doesn't tell you what you want. It's just and the math is kind of subtle, and I don't really want to get into it, but it's not the right answer. So what you can do instead is you go format trend line, type, and then depending on what exactly you want to do, you go logarithmic. You get a straight line, but it's in a funny place. What you have to do to get the line that I showed you in the last graph is you have to go back and get rid of some of the data. You have to get rid of the zero values. You go back here and you move this down until there's no zero values. And then come here. And now it should let you choose the power law option. And you want to make a note of that. That is the option that produces a nice straight looking line. And then if you put the option to display the equation on the chart, up what the equation is doing is it's telling you that y increases to x to an exponential power, and the exponential power is greater than greater than 1. And for the scientists among us, this is very meaningful. For the rest of us, all it means is that the trend is faster for the total than it is for the invoices. The totals are growing faster than the invoices are. And you can establish this by an easier method, by a much simpler and less scientifically daunting method. You just plot the average, as I did back here. Instead of plotting the totals, plot the average. And if the average seems to go up, why then you know. And you don't have to think about exactly what this means. You just look at this line and go, oh yes, look, it's going up, not down. The larger vendors have larger average invoice sizes, which means that the number of transactions is not growing as fast as the total volume. So now I've shown you very quickly how to get this graph. I've shown you why it's infinitely better than the graph that Excel gives you on its own. I've given you some terminology. You know what a log plot is. And that's a bit plotted every day. But now we got to step back and think about, how is this going to help me do a better audit? How is this going to help me pick a better sample? So let's look at this graph of the total volume and the number of transactions, and see what things we can learn. See what things are evident just from looking at the graph. And the first one is there's this very interesting striation, this very interesting grouping of the data. And that's because, of course, you've got one transaction as the very first possibility. This is 2 transactions. This is 3. This is 4. Each grouping is all the vendors who submitted exactly 1 or 2 or 3 or 4 invoices. And so just at a glance, just by looking at this, you can say, oh, look, the number, if you have a sort of a weighted mean, like if you look at where the middle of this group is. So now, if you look at these little pillars, these little rows of data, you see that there's a kind of weighted mean. You can see that the middle of this line is somewhere down here, and the middle of this line is higher up, and the middle of this line is higher up. It's a cool way to produce the average for each type of vendor. The vendors who produce exactly 1, or the vendors who produce 2, or the vendors who produce 3. You're actually kind of giving a visual summary, which you really couldn't do any other way except by this kind of graph. And you can work your way up until, of course, there's so many transactions that it all kind of blurs together. But what I'm trying to get at, what I'm trying to leave you with after a half an hour of graph making, is you have a tool here to start thinking about your sampling in a more creative way. You can start thinking about your vendors as belonging to different size categories. That the vendors who produce small numbers of invoices also produce not only smaller dollar volume, but smaller volume per invoice. Their invoices are different. You're thinking about, what is the qualitative difference between a small vendor and a big vendor? You know, are we important to them? Are they important to us? What's going on with these individual transactions? So you have an opportunity by making this graph, just by doing the steps I showed you. It only takes a couple of minutes. You have an opportunity to inject some insight and some creativity into your sample selection process. Now, I said at the start that I wouldn't actually teach you how to do a different type of sampling. All I'm trying to do is open your eyes to the possibilities of there being a better way. And that with a little work, with a little bit of practice at graphing, you could become more insightful into how your data is structured and to what sorts of things are going on in it. Just as one final example, something that you can chew on, think about as you go about your day. You look at this trend line that we constructed, that Excel constructed for us, this exponential trend line. You don't need to worry too much about how this equation works. just think about the fact that this is the authentic trend, and that this scatter plot shows how far we are from the central trend for any given item. Now, what's this guy doing out here? He is a long way from the trend. What's this one doing out here? Or this one? This one, you'll notice, this was $19 million worth of transactions, but only 3 invoices. This is one of the ones I pointed out in the data set, but he was going through it earlier. And this one down here, you have 952 items worth a grand total of $3,934. Now, I don't know about you, but I don't want the expense of processing 952 items that are worth about $4 a piece. So I think that there's a case to be made for investigating this one, and I think there's a case for due diligence on this one. So just by plotting the data in this way, you've created insight into which items might be highest priority for investigation. The ones furthest from the trend line would be a good place to start. And with that, I think I'll leave you. You're bound to have some questions. I'm going to take you back to my show. Okay, so that concludes the presentation. I hope that what I've left you with is one new skill in graphing, one new term that you'll recognize if you see it again, the log chart, and one insight into your data that you didn't have before seeing this presentation. I hope that when you next come to try and sample data, or you next come to plan an audit, that you'll think a little bit about the structure of the data, and you'll think that maybe there's an analytical method that would give you some insight before you create your sample plan. So that's the gist of my presentation today, and I thank you for listening. If you want to contact me, my information is there on the screen. I welcome all inquiries. Please don't be shy.